Okay, so in this video I'll go into a little more detail how defense works and how we can use it. Basically, it all comes from the damage formula given here. Basically, at level 100 it's 0.84 times the attack corresponding to the style of the type of move used times the base power of the move used over defense plus 2. This whole numerator is a function of just how strong the attack is, and since we're concerned with defense more in this video, we'll call it K, just to simplify things. It's worth noting that K is generally really big compared to all the other numbers you'll see. One interesting thing about this formula is this little plus 2 here, which really makes all this math a lot harder than it should be. But basically, I guess what Game Freak decided was that each move should do at least 2 damage. I guess since otherwise Menopod versus Menopod would take all day or something like that. Anyway, it doesn't actually have much of an effect in competitive Pokemon where everything happens at level 100 unless you're in the Little Cup or something like that. So if you want to pretend it just doesn't exist, like I for one won't tell, it makes the math a little more complicated, so it's really inconvenient, but there it is. Anyway, so we have this damage formula, but what we really want is to know how much harm your Pokemon is taking in terms of a percent of its overall health. So that's easy enough. Basically, you just divide by your HP stat. So you get the following formula. HP is abbreviated as H. And yeah, with little rearrangement you can get the K on its own and get the 2 over H by itself. And since K is really big compared to the other ones, this 2 over H term is not going to do very much. It's not going to have a big difference on your harm. So just keep note of that. Anyway, so if you want to do calculations just concerning physical or just special, this is the formula you want to work with. But for most of the time, you're going to be taking hits from both ends of the spectrum, so you want a formula that will account for that. So here we have the overall harm. Basically, it's like assuming that you're going to take a hit from the physical side and from the special side, and that they're both exactly the same power. And as you can see, the harm is just a sum of the physical hit and the special hit. With a little more rearranging of variables, you can get it into this form, which is a little nicer, I guess. I've highlighted the 4DS term because that's the one that kind of goes away when we're at level 100. So, what can we do with this? One interesting and helpful thing you can do is take derivatives. Basically what you're doing is finding out how much each stat affects your overall harm. So if you take derivative of harm with respect to defense, you get this formula. If you take derivative of harm with respect to special defense, you get this here. And if you take the derivative of harm with respect to your hit point stat, you get this ugly thing right over here. You'll notice that they're all negative. Basically, this means that if you increase any of these things, your overall harm will go down, which is what we want. Okay, so that's a little abstract, so let's find something more concrete. Let's take Blissey and run the numbers and see what happens. First of all, the derivative of harm with respect to defense. We get K over about 2 million. Well, that's fine. We know that if you increase your defense by 1, your overall harm will go down by a factor of K over 2 million. Great. So let's take the derivative of harm with respect to special defense. We get minus K over about 61 million. That's quite a bit less than the first one. If you can't see why, don't worry, we'll get to We'll actually run some numbers here in a sec. And lastly, there's the derivative of harm with respect to your hit point stat, which is this really ugly thing, which simplifies into this slightly less ugly thing. Anyway, let's see what they actually are. We'll plug in some arbitrary value of k, sufficiently high arbitrary value of k, as 100 million. This k value is actually a lot higher than you should expect to see in combat, but it makes the numbers nicer, so we'll keep it with that. It doesn't change the actual relative values that much. Anyway, the derivative with respect to special defense is minus 1.6, which means that your harm goes down by 1.6 by adding special defense. With respect to hit points, it goes down by 5. And with respect to defense, your harm goes down by 49. Basically, this means that if you give your Blissey a defense EV, it'll have about a 10 times stronger effect on your Blissey's overall defense than if you give it a hit points EV, and about 30 times as much as if you give it a special defense EV. Overall lesson: give Blissey defense EVs. It really helps Blissey's survivability a lot. Okay, so what else can we do? One fun thing we can do is turn this into a little optimization problem and find out what the best combination of hit points and defenses should be. To make this easier and get rid of some variables, instead of working with hit points, defense, and special defense, let's work with just one number. Arbitrarily I pick hit points, and the total of all three, which we'll call P. Also, since we're not putting any bias on defense or special defense, we can set those equal to each other. Since our EVs are going to be divided between special defense, defense, and hit points, we know that special defense and defense are going to be P minus hit points divided by 2. So we can go back to our overall harm formula, back a few slides, and substitute S and D for this expression here, and we get this. This is a really convenient equation because the only variable here is H. Remember that K is a constant that corresponds to how strong the attack is, and P is just the sum of your hit points, defense, and special defense stats. So that's ultimately going to be the same no matter how we distribute the EVs. So that's a constant too. So on with the optimization. Basically what we can do is take the derivative with respect to H. This gives us this formula. Now, the most interesting part about this is when this expression is equal to 0. That's the point when no matter how you change your hit points distribution, your harm is always going to go up since you're already at the minimum point. If you set this equal to 0, you'll get this thing, H equals K plus P minus root KP plus K squared, which is really kind of cryptic and hard to understand anything about it. But remember that K is probably going to be a really big number. P is going to be kind of high because it's a sum of 3 stats, but it's still not going to be as big as K. So one thing you can do is take the limit as K approaches infinity, and this actually turns out to be rather nice. It's just P over 2. So what have we learned? Basically, if H is P over 2, then D and S both have to be P over 4. This is where the 2 to 1 to 1 ratio comes from. Basically, if P is your total amount of hits, defense, and special defense, a full half of it should be hit points, while a quarter should go to the other 2 defenses. While it would be really great if you could say that this was completely true, unfortunately it's not. The problem comes from the slide before when we assumed K was infinite, which it really isn't. It doesn't have too much of an effect on the actual point where hit points is optimized, If you want to find the exact point, you should run the numbers specifically for your Pokemon and for the attack that's incoming. But most of the time, you should just add some hit points. Make the ratio like 2.1 to 1 to 1 or something like that. So a couple last thoughts. Basically, this process of taking the derivative, finding zeros, and finding a specific H works for any combination, any bias towards defense or special defense, not necessarily 50-50. Also, while it'd be sort of funny if Pokemon allowed you to put square roots of EVs onto your Pokemon, that you can't. You have to have integers, and because of that, Pokemon round stuff a lot. So one of the consequences of this is that your stats won't always go up by 1 just by adding 4 EVs. Sometimes they'll go up by 2 randomly, seemingly randomly. Anyway, the point is that if you completely rely on the math, you might be missing an opportunity to abuse rounding. So once you have your optimized result, you can still play around a little bit with the numbers. It's possible you'll find an even better combination.